A warm welcome to Productronica 2017. The special shows here are a big highlight, because that's where you can experience electronics manufacturing live. Founded in April 2017, the research fab Microelectronics Germany. This is where research capacities all over the country are bundled together and connected to give the fab more weight internationally as a center for microelectronics. Dr. Olowinsky, hello. Laser microwelding. What exactly are we looking at here? Laser microwelding is an established method in electronics and precision engineering for creating electrical and mechanical connections. Here you can see a laser beam melting material, and that's what creates the connection. In this particular version, the laser head contains the beam guidance, beam forming and mechanical pressing combined for a flexible manufacturing process. And what are the areas of application? What you see here, classic battery technology, production of battery modules and packs, production of electrical connections, all the way to printed circuit board technology, because we need to create connections there too. Dr. Olowinsky, thanks a lot. From microelectronics to the special show devoted to hardware data mining. With me now is Ulf Österman, business developer at Fraunhofer IZM. Good morning. Mr. Österman, what's the connection between microelectronics and hardware data mining? The research fab Microelectronics Germany is supposed to develop technologies and processes for the future, and they then have to be ported into mass production and scales so that they're ready to use there. That's exactly what hardware data mining is all about, showing what data records accumulate at what location in the individual process steps and how robust they have to be in order to be used. So we're talking about digging data. Can we take a closer look? Sure, no problem. Based on the data matrix code, you can immediately establish when this subassembly was manufactured, at what temperature, in what humidity, and then conclusions can be drawn about possible errors. I guess it helps save on resources, only having to replace individual components. It's showing how thick wire is bonded. A very, very large number of wires are needed to get a high current density in the contact. Mr. Österman, thanks very much for the tour. Hardware data mining. I'm going to the VDMA now to see what's being done with the data. And you, back to work? That's right. Okay, thanks. Ciao. We've just mined and collected the data. The data has to go somewhere. It has to be processed. And that brings me to the special show of the VDMA. Smart Data Future Manufacturing. With me now is Mr. Müller from the VDMA. I've just taken a look around your stand. There's a lot of data being generated here. What's going to be done with it? In the next stage, it's simply stored in various cloud systems to make the long-term data actually usable. For models, for instance, like predictive maintenance. Smart data. How do you see the future of that? A very exciting future topic is machine learning, where companies try to make machines learn, so they can avoid errors, or correct them, all by themselves. Wow, thanks very much, Mr. Müller. Smart Data Future Manufacturing. It's a topic we're going to keep a close eye on. Well, that's all from Productronica 2017. I'm already looking forward to 2019. Goodbye.